All right, so we're making some progress, and again, recall that the appearance of text rectangles allows to control the visibility of the text that it contains, right? So it can be visible, it can be invisible, and it can be then made visible again. So how is this managed? So this is the idea. Let's bring it back to a view like this. So we do this through these two functions, text hide and text show. By the way, one other detail that I would like to tell you is that once I copied declaration of text show, it includes the default value for the function parameter, and this default value for function parameter can be specified only inside the header file. It should not appear as part of the implementation. So I will actually get rid of it. Okay, that's important. Otherwise, it will be a syntax error when I compile it. So that's an important step in providing this implementation. So the hiding and making content visible is done entirely through the set color of the text. You see how we say, okay, if we have a text, okay, which contains a string of characters, and set its color, the color of the text, if we set it to the same color as the background of the rectangle, the color which the rectangle is filled with, then very likely this text will become invisible. So like here, the stops word exists here and is actually printed, but it's printed with the same color as the background container, which is like this white rectangle that contains it. And this is how the hiding is implemented. And the showing of the text is done through basically setting some color other than the background, like black, blue, green, whatever the decision is on your part. And so that's the idea how this text rectangle is capable of basically taking these calls, right? Hide and show text, and manipulate the visibility of the text. Now, also remember that in the current implementation of this graphics library, what happens is that if we change the properties of these gadgets, their appearance will be refreshed automatically on, so we don't have to like go through some more difficult call protocols to tell the window that we need to change or update one of the gadgets. When we use these set color calls, the update on the window is done instantly, automatically, and the effect takes place immediately. So this is, again, for convenience, this is a perfect setup, and this is something that we can use to our advantage to make these elements of this graphics library somewhat useful to more or less interactive program that can be used. Okay, so that's the plan with hiding and showing the text. So what we did so far, right? If I now go back to display this side by side, right? So I have implementation for functions show and hide, which is right here. Show and hide, this is complete. I have font management all done already by delegating these calls directly to the text object. So what's left on our to-do list is to implement the actual display and to provide the constructor for our brand new gadget, text rectangle. So let's go back to our handout and resume where we left off. So we were working on the text rectangle portion of this. And we've gone as far as putting together all of this. So the constructor, okay, so the constructor that we need, again, delegate the work to the constructors of the rectangle from which we inherit, right? So we have basically this text rectangle structure that we're working on uses rectangle as its base class, and also uses the text as its member, data member. So basically, at runtime, if you want to make it visible at runtime, let me actually do this a little demo once again. I'll simply duplicate what I have right here. Okay. Duplicate and show you. So this is like a design time class diagram of the classes that are involved. But this is the runtime diagram. So at the runtime, so I'll just remove these relationship, because relationships exist between classes, but at runtime these relationships transform to something different. So basically, text rectangle becomes an object. So let me kind of draw its, draw it as an object, because this is the actual object which is created and occupies some memory. So I draw objects that occupy memory as boxes. So is the text. The text is also going to be an object in memory when the program executes, right? So I convert it to a box. Like I said, this is right here. This is the design time. Okay, let's actually say this. This is, if I resize it, this is something that we would refer to as a design time class diagram. And this is on this side a runtime view, as if we were able to see what's happening inside computer memory, right? We would have rectangle object and the text object, which come from the memory, but the text rectangle, okay, so this is now, I will now sort of remove its box from our demo. And so what's going to happen to the text rectangle, that the text rectangle essentially will, try to position it better on this view. Okay, so the text rectangle becomes a box that will contain all of this internally. Okay, so I'll just move my label here up and complete this demo by showing you that at runtime, the text box will contain both of these objects. So it will be a big box wrapping itself around this, around the two, around the rectangle and the text, because this one we inherited. Okay, the rectangle we inherited, and the text we included by making it a data member of our text rectangle class. So this is how it becomes, this is what it all becomes at runtime. So this is the runtime view right here versus the design time view. So programming languages which support object-oriented features allow you to design these classes individually, but they can be combined because of their relationships into a certain organization of memory. In essence, object-oriented design in its most direct application is a way to manage computer, right? So we will say that this object contains internally these two objects, and one is done through the inheritance, and another one is done simply through the containment. So once again, in the code, if we look at the code, this is the inheritance part right here, because the text rectangle inherits everything from the rectangle, and therefore rectangle becomes part of it at the runtime. And on the other hand, we also say that, by the way, in the memory of this text rectangle, in its scope, we always have a copy of the text gadget, which is right here. So therefore, we always have them, and we can always interact with these two objects when the text rectangle is in memory. And that's what we're doing inside of our function implementations, right? So this is why we say text, do this, do that. And when we work with the rectangle, like right here, when we want to call the rectangle function, we can qualify it with rectangle reference and the fill color. I would also suspect, because we have sometimes collisions with with Windows GDI library, I think that I would prefer to qualify this rectangle also with our own namespace. I think that would be a better idea. Let me check if I have any other. No, this is it. So this is where I want to use, just so that we specifically say that this is our rectangle that comes from our namespace. All right. So with this in mind, back to the handout. This is the constructor. So the constructor, the nature of the constructor is that what constructor is responsible for, our text rectangle constructor implementation is responsible for constructing the base class, which is the rectangle, and then constructing every data member of our text rectangle class. And this should be the completion of construction of the outer box of the text rectangle box. So how is it done? Let me just copy and paste this constructor to implementation file, text rectangle.cpp, or implementation file. So I'll just copy and paste it right here. Change the indentation, and once again, the first step is to qualify this constructor, which is a member function of our text rectangle structure, qualify it with the name of the structure to which it belongs. So it kind of looks a little silly with text rectangle name, but this is how C++ constructors all the time look inside the implementation files. I also prefer to use name of the file at the top of the file. So I typically go here, right-click the tab of the file, copy full path, and then use a comment with this, but then I will remove the entire path and just keep the name of file. I prefer to keep this type of comment in my implementation files, and you can see in my header files as well. I find it helpful for some reasons. And of course, by the way, I'm assuming that this implementation file has to know what is text rectangle, and this is done by including the text rectangle.h. Include text rectangle.h. I'm pretty sure we need this in our code. So therefore the structure becomes available before we begin to provide implementation of these functions, and that's what compiler is expecting. Basically, it will be saying, what is this? And by the time we include this header file, compiler will know that text rectangle actually is a structure. All right, so this is how we delegate construction, right? Construction of rectangle and text inside the constructor. We use this is the colon right here. This text, this syntax element, is constructor initializer list. And constructor initializer list is capable of using references to the base class, right? So the rectangle is our base class right here. So we say, let's first construct the base class object by using its own construction, its own parameters that are required by the rectangle constructor. And we delegate the work to the rectangle constructor. So this line here constructs the rectangle box, and we say it needs to take the point, it needs to take the width and height, and this will construct the rectangle. Then we construct the text box right here by saying text, which also needs to take the point. And since we want to make adjustments to the position of the text inside this rectangle when it all becomes visible, we add this we take some adjustments here to adjust the position of the initial point that was provided. We will talk about this later on when we make the program runnable. We can change this and make some experimentation with positioning right here. And the text gadget naturally also takes the string. So these are the parameters. Let's make them all visible. So when we construct the text rectangle, we have to specify the top left corner of the rectangle, the width and height of the rectangle, and then also the string of text that should be shown inside of that rectangle. So this is the implementation of the constructor. We're almost ready to now run the demonstration of it, basically be able to compile everything. But remember, I'm unable to compile it just yet because there will be a lot of error messages, simply because text rectangle is still unfinished. But we're trying to start our project by using the demonstration of the text rectangle. So in the first place, we're trying to complete the implementation of the text rectangle concept using text rectangle structure and all of its data members. So let's try to do this in our next segment. We will basically focus on the draw lines, and we will discuss it next. So this will be our next step.